So we completed the binary search algorithm, example on that, right, some numerical example, right, algorithm followed by time complexity, everything perfect, right. Now let's see how the questions will come on binary search. On binary search, how the questions will come, many questions came. Now I will explain, minimum 5 examples I will explain, minimum, right, please be careful. Many questions came in the previous papers on binary search, right. So this is the one of the problem, read it. This is the one of the problem which is there in the previous papers on binary search. Example, what the, right, one example, I written the example here. So many questions came on binary search in the previous papers, right. So one problem I written already, right, see this one, example 1, right, example 1 example, right, read this one. Input, a sorted array of n distinct elements. Output, find any index I such that ai is equal to I. This is the given problem and they are asking what is the time complexity. This is the input, this is the output what they are expecting. So to solve this problem, what will be the time complexity? Input is clear, output also clear. To get that kind of output, what will be the time complexity they are asking? And one more thing I want to ask you, right? What is the time complexity they are asking? Are they asking best case? Are they asking worst case? Anything are they written? No. When they ask you what the time complexity, meaning is going to be, if you write best algorithm, not best case. If you write the best algorithm, to that best algorithm, what will be the worst case? Worst, everyone interested worst case only. Suppose God want to test you, are you really good human being or bad human being? So God will keep the one test to you. He will check worst case how you will behave. God is seeing from top. And he will verify, he will keep one test on you and he is checking like this one, worst case how he will behave. Suppose isn't that, right, God knows that it is a really complex test because you want to test worst case what is your behavior. Suppose isn't that by seeing that test, worst case you went for, assume that you went for suicide attempt, assume, worst case. God got to know, okay, he is a brainless person, it is a dust only. God got to know. God having sometimes some doubts on us, right? He is really great person or not. He want to verify. He will keep some test and he will see worst case how he will behave. If I drag as much as possible, right? Worst case how you will behave. Suppose, right? In the worst case also you are smiling. In worst case also you are smiling. God got to know that he is a very dangerous candidate. So he will also laugh. You are laughing, he will also laugh. Right? He don't do any test on you. You please be careful, any test will come, right? Please smile it, please accept the challenge. Please try to resolve the problem. Think about that, use brain. Any complex problem came, please smile it, right? Please find the solutions for that, right? And so on. For small things also, I am able to see in the newspapers and all, for small things also, they will go for suicide attempt. They will do some unnecessary things. If you really great person, I am saying to you, right, worst case how you will behave, that really matters. Worst case also are you smiling, then you are really great human being. Right, please be careful. Now finally, directly I want to say to you, what is the time complexity? What is the meaning? Worst case, what will be the time complexity? If you write best algorithm, right, we will see now. Some people may say that, sir, I have one algorithm to solve this problem. How I know it is the best algorithm or worst algorithm? That is the place where you have to do practice. When you are practicing many questions, you will get to know, okay, right, this is the algorithm I know, actual algorithm is this one. Right, you can remember that also. You keep on improve. When you do a lot of practice, you will get to know how many algorithms are there, which one is the best one and all. Please remember, we will give within the syllabus only. Any question is given in the GATE examination, within the syllabus only you will give. What is the meaning? That algorithm you studied already. If you do some enough practice, all algorithms you remember like this one, you will give answer directly. Please do enough practice before exam. Right? Again I am repeating. Time complexity they are asking means best algorithm, if you write, what will be the worst case? Right? To this problem, what is the best algorithm, what is the worst case, I will explain. Some people are doing reverse order. What is the meaning? They will write worst algorithm, further best case they will find out. There is no use at all. Worst algorithm, best case, what is the meaning in this? right? Best algorithm you write with your capabilities, whatever you are thinking, whatever practice you done with your capabilities, best algorithm you write, right? To that worst case, right? We'll see now, we'll see. Can you say what is this problem? One sorted array is given which contain n distinct element. Please be careful, distinct elements, right? Distinct elements are there. Let me write distinct elements, n distinct elements, and sorted array. Next one, you have to find any index I such that ai is equal to I, right? What will be the time complexity they are asking? So I will try this, I will try. See how to solve this problem, I will try. So see the example also, array A, one example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, some index, I have to give indexes, I am giving, don't worry. These are the indexes, 10, 11, 12, 13, 14, 15, 16. I am taking more elements so that I can explain clearly, right? Don't worry. So I should take one array, I took larger array so that I can explain clearly. So, and one more, is it sorted or unsorted? Sorted array. And one more, is he mentioned positive, negative number, something like that? Is he mentioned anything like that? No. A sorted array of n distinct elements. And distinct elements you can take anything, positive, negative, he didn't mention anything, right? Let me try this one, right? But one thing, sorted array, right? Let's see this one. Minus 50, minus 30, minus 20, minus 10, minus 3, minus 1, 0, 2, 5, 9, 11, 15, 25, 30, 50, 80, 90, right? This is the array. These are the minus. Please be careful. Lack of space, I arrange it like this one. Minus 50, minus 30, minus 20, minus 10, right? Minus 3, minus 1, 0, and so on. If you want, you can check it in increasing order. So in this array, what is your goal? In this array, find someone where position and value both are equal. I think I have to find this. This person I have to find out. In this array, find any person. Suppose some people are asking, sir, many people are there like that. Many people, suppose 11th place, 11 there, 12th place also 12 there, 13th place also 13 there, then which one you will return? What he mentioned? Find any index. See this one. Find any index I such that ai is equal to I. Anyone you can find out. If many there, give one person, that is okay. Whom you will give, whatever you like you can give. There is one array, in that array, that is a sorted array, that is okay. Negative, positives, because of he is not mentioned, I took negatives also. If he say only positive, I could have taken only positive, right? In this array, which is the sorted one, you can take a positive, negative, any number, but our only goal is going to be position and value both are same. You have to find out that person. Suppose many people like that, find anyone, I don't have any problem, right? To do this is asking, right? Best algorithm, if you write, what will be the worst case time complexity? Can you help me now to solve this problem? What is the one of the answer which you got immediately in your brain? By seeing this problem, immediately in your brain, one algorithm you will get. Can you say what is that algorithm? Most probably you know very well. It is the linear search. You can apply linear search. So always remember, your goal is best algorithm. It's okay. Your goal is best algorithm. But by seeing that problem, immediately you will get one algorithm. Start with that. To solve this problem, immediately we will get one algorithm. In examination, not only this problem, any problem, first apply that. First apply. You will get to know pitfalls. First apply. Right? Can you help me now to solve this problem? What is the one of the algorithm? Linear search. Some people are asking, sir, how to do linear search? Take one for loop. Linear search means what? Asking everyone. Right? Take one for loop. Ask like that. For loop is starting from 1. Right? For I is equal to 1 to 17. Right? Let's start. ai means a1. a1 is equal to 1. No. a2 is equal to 2. No. a3 is equal to 3. No. Like that, keep on ask. Keep on ask. Right? Here matching there. a11 is equal to 11. Yes, stop. Then can you help me now? To this algorithm, the algorithm whatever we are talking, linear search. If you apply linear search algorithm on this problem, what will be the worst case time? Assume that to this problem, best algorithm is linear search only. For some problems, linear search only best. That is the reason don't escape, right? Any problem is given. Please try whatever you are thinking about that. By seeing this problem, I remember that linear search is possible. Let me apply. Linear search is possible. I applied, I got to know A11 is equal to 11, I can stop. Can you help me now? If you apply to this problem linear search, if you apply the linear search, you only say, what is the worst case time? What is the worst case time? What is the answer? I think last one may match. I think answer is order of n worst case. Because you have to ask every person. Just scan one time. A17 is equal to 17 sometime. Surrounding to last place, you may be worked out. So that is the answer. Can you help me now? To this problem, right? One algorithm you got. What is that? Linear search. What is the worst case time? Order of n. Now after seeing this problem, you thought that linear search is the answer for this one, right? Time complexity worst case is order of n, right? Everything is fine. Assume that only answer. Then what will you do is, after seeing this answer, just go to the options. You verify the option. In the option, right? What is the answer you are expecting? N. In the answer n is there, right? In the answer n is there. Less than n, no one there. In options n is there. Less than n, not there. All are more than n only. Then your answer is best. You can stop it. After getting your answer as n worst case, right? Go to the options. Options you verify. Is there anywhere n? Yes. N is there, don't select n. N is there, it's fine. Less than n, no one there. What is the meaning? In the available one, it is the best one. Right? You can stop it. So sometime I think, even though the worst algorithm, best algorithm doesn't matter. Right? Whatever you got, please do that first. See the option. According to options, you have to try. In the available one, best one you have to select. I think if you are lucky, what will happen to this problem? N is there in the option, less than n, no one there, you can stop. That is the answer. Suppose, assume that n is there. N is there. Less than n also there, right? That is a log n. Less than n, log n there. What indirect signal is giving? You applied the linear search. In the option, n is there. Less than n, log n also there. What is the indirect signal they are giving? You can apply binary search also. Maybe they want to say that. Everyone, what is the improved version of the linear search? Binary search. So linear search is already answer confirmed. But less than n also there, which is a log n. I think indirect signal. Okay, maybe you want to say that binary search is possible. Right? Can you say binary search algorithm to apply? What is the prerequisite? Array should be sorted. I think it is sorted also. So by seeing that n is there, less than n, log n also there, I got the idea of binary search may be possible. From today onwards, you remember, at anywhere if you see log n, maybe they are indirectly giving signal to you. Binary search may be possible, please check. Right? Please check. Binary search is possible or not. Is array sorted? Yes, that also. I think one more signal. I think binary search may be possible or not, I want to verify. By seeing array sorted, maybe binary search possible. Right? I will try that also. Please listen properly. Please listen, binary search is possible or not. Can you help me now? Binary search algorithm first step. Problem small or not? No, not small. It is big. I want to apply binary search is possible or not? Let me try now. Problem small or big? Big. Now, if it is a big, what is the mid element? 1 plus 17 by 2. Mid element I am finding. 1 plus 17 by 2, 18 by 2. Which will goes to 9. Mid element is 9. Right? Mid element is 9. Right? I got to know binary search may be possible. That is the reason I am trying. So is it small problem or big problem? Big problem. Then find the mid element also. Yes, 9. Right? Mid element is 9. Carefully listen. Mid element 9. Just go to 9th place. Right? Mid element is 9. Just go to 9th place. Ask the 9th place person. Are you 9? My position is 9. It's okay. Your value also 9 or not. Right? When I ask him, can you help me? If you are lucky, what will happen? Middle person I am asking. My position is 9. Value also 9 or not, I am asking. If he say yes, then stop it. That is the reason. No one will ask you best case. To this algorithm, right? We are not trying the best case. We are trying worst case. Right? Middle person I asked, are you my element or not? Means what is the way of asking? Position is 9. Position 9 is equal to value also 9 or not. If he say yes, stop. Because of he is not saying yes. Right? Now I am in the middle. Right? He is saying no. But I am unable to decide whether should I go left or right. Should I go left or right? I am unable to decide. So can you help me? I am in the middle. I am in the middle of the array. Right? I am unable to decide which side I have to go. Suppose assume that using nice logic you are able to decide I can go left only. Right? I can go right only. You are in the middle, you are able to decide which side you can go, then binary search possible. Suppose assume that you have dilemma, then binary search not possible. What is the meaning of binary search? One side you have to go. Suppose assume that without any dilemma, you are able to say clearly, I am going left side because of this reason. If you say clearly, then binary search possible. From the middle, if you can select one side properly, not blindly, properly, right, then binary search possible. Otherwise, not possible. Let's check. Am I able to decide or not? Can you help me now? You only say, 9th place is 9 is there? No. So, whether I have to go left or right, I am verifying. See the answer. See the very interesting answer. See this one. 9th place 5 there. You only say 9th place 5 there. That is fine. If 9th place 5 there, can you guess now what is the 10th place? Try to remember, array is in the sorted order, increasing order, distinct. See, there is no repetition also. All are distinct. Please be careful. 9th place 5 there, 10th place what will be there? What is the answer? If the 9th place is 5, 10th place should be more than 5. When you say more than 5, there may be a chance of 10 also. 9th place 5 means, right, 10th place should be more than 5. More than 5, in the more than 5, 10 also there. So, I think there is a hope on the right side. 10th place 5 means, 9th place 5 means 10th place will be more than 5. More than 5, 10 also possible. There is a hope on the right side. Some people are asking, is there any hope on the left side? Let me check that also. 9th place is 5. Can you help me now? If the 9th place is 5, what about 8th place? 8th place will be less than 5. Less than 5 cannot be 8. No hope. 9th place is 5. That's okay. 10th place will be more than 5. More than 5, 10 may be possible. Hope is there. But 8th place, less than 5 cannot be 8, no chance at all. So, you can stop. Can you help me now? Which side I have to go? Go right side. So, I am able to say clearly, right, one side I am going because of this reason. You have to say the reason, I am going right side because there is no hope at all on the left side. Hope is there, you can go. Supposing that it is looking like both the side hope is there, then binary search not possible. Both the side hope is there. This side may be, this side may be. What is the meaning? I think because of both sides there, right, you have to check this side also, you have to check this side. If you check both the side, how it is a binary search, it is called linear search. So, I think now I am clearly able to discriminate. Right side is the one which you have to go. Some people are asking, sir, can you check further? Let me check. I am checking also. If you want, you can check. Once again, in this area, binary search, you only say. In this area, if you want to apply the binary search, what is the first step? Is it small problem? No, big problem. Can you say mid element? 10 plus 17 by 2. In this area, binary search. Mid element is going to be 10 plus 17 by 2, which will go to 27 by 2. 27. What is the answer? 27 means how much? 14, I think 13. 13 point something. 13 to 26, right? 13 point something. 13.5, whatever it may be. Take the floor value, right? 13. You can take 14 also, you can take 13 also. It is not a problem, right? Just see the logic. So, I think as per the algorithm, I followed. Just do the by 2, 27 by 2, 13 point something. I took the floor value, 13, go to 13th place. Ask the 13th person. 13th place, whoever is there, I am asking. Position is equal to value or not? If he say yes, stop. If he say no, see the story. If he say no, see the story now. Please listen. 13th place 25. You only say. If 13th place is 25, what will be 14th place? 13th place 25, I am okay. What about 14th place? More than 25. More than 25 cannot be 14. Can you help them? 13th place 25. What about 12th place? Less than 25. Less than 25, there may be a chance of 12. 13th place 25. 12th place should be less than 25. Less than 25 may be 12. Right? I think there is hope on the left side. Then go left. Carefully see what I done here. Two things I explained. Why I am going right, I explained here. Why I am going left, I explained here. Right? Here right I am going, I explained the reason. Here left I am going, I explained the reason. Please be careful. Once again, binary search in this area. Once again, small problem? No, big problem. Mid element. What is the mid element? 10 plus 12 by 2 positions. Which will goes to 22 by 2. Which will goes to 11. Right, 11 is the middle person. Let's go to ask the middle person. 11 I am asking. Are you position and value both are same? Yes, stop it. So, like that you can do. Right, please be careful. So, binary search is possible. Can you help me one small line? When can I say binary search is possible? When can you say? Just go to middle. You are in the middle. You are right. You are unable to decide. It's looking like both the sides possible. Then binary search is not possible. It's looking like that. Please do careful action. Right? Suppose I am able to find one logic, right? To say that I am going right, this is the reason. I am going right, this is the reason. If you find logic like that, clear reason, I am going, my element is on the right only because of this reason. My element is on the left only because of this reason. Then binary search is possible. Right? Please be careful. Can you say this algorithm best case? Best case 1. Worst case is going to be log n. So binary search is possible. Answer is going to be log n. Let me check here. To this problem, linear search possible, it's okay. What is the one more? Binary search also possible. Let me write. Binary search also possible. What is the worst case? Order of log n. Right? Worst case and average case. You will ask worst case only. No one will ask average case. But anyhow I written. Best case 1, it's okay. Right? Now can you help me? Some people are asking, sir, what is the logic here? Can you give the logic? If you want, I will give logic. See this one? See everyone? Position and value. Binary search algorithm also I am writing. Rough algorithm. See this? To this problem, rough algorithm I am writing. Binary search algorithm roughly I am writing. Position value, compare. Position and value. See this one? In this one, it is the position. It is a value. See this one? Compare the position and value. If position greater, which side you will go? Position and value. Position and value. If the position greater, which side you will go? Right side. Go right. Else go left. Here see this one. Position and value. Position and value. If the value greater, go left. This is the algorithm. Nothing there. It is a binary search algorithm. To this problem, binary search is possible. This is the logic for that. If both equal, no problem. Both not equal, position and value not equal. If the position greater, go right. Otherwise, go left. Please take one more example. You check yourself. And one more. Now the question is going to be to this problem. How many algorithms possible? 2 algorithms. Linear search also, binary search also. You want any algorithm or best algorithm? Best algorithm. Best algorithm, best case or worst case? Worst case. Answer is log n. Please be careful. To this problem, answer is going to be. To this problem, answer is going to be what is the answer? Right? Log n is the answer. Worst case is going to be log n. Now, after getting the log n, please go and see the options. Is log n there? Yes. Less than log n there? Less than log n there? There may be, if at all someone is there, less than log n, someone there. Please check with your available knowledge. Please verify. Right? Is it possible or not? If not possible, right? Log n is the answer. Mostly log n is the answer. If less than that is there, please verify that also, safe side. But one thing, do this kind of work before exam, so that in the exam directly you can give answer. Now some students are asking me, sir, how I know that binary search is possible or not? I am in the middle, I am unable to decide which side I have to go. So binary search is not possible. I have dilemma. This may be, this side may be some dilemma. That dilemma I am unable to solve it. Indication that binary search may be not possible. Right, one thing is you have to believe yourself. CSE person saying that, a computer science person is saying that to this problem binary search is not possible. Mostly it is not, because you know binary search very well. Right, I am in the middle, I am able to say go right only in this circumstance, because left no chance. If you can decide some logic like that, then binary search possible. Right also say the reason, left also say the reason. Then I can say that binary search is possible. Right, to this problem answer is log n, worst case. Right, if log n is not there in the option, linear search you can select. And one more thing I want to ask you. See this one? One more thing I want to ask. Suppose, same problem. Sorted not there, binary search not possible. Right, this one. Sorted is sorted array, right? Sorted array not there, assume that. Then binary search is not possible. Please be careful. And one more. Sorted is there, careful listen. Sorted is there, but distinct is not there. Then also binary search not possible. Please verify yourself. Sorted keyword not there, binary search is not possible. Next one. Sorted keyword is there, but distinct keyword not there. Then also binary search not possible. These two not there, or any one not there, binary search not possible. Because of in this problem both are there, binary search is possible. Now can you help me? What is the answer of this problem? If sorted keyword not there, n, linear search is the only hope. What is the answer of this problem? Right? If distinct is not there, n, linear search only possible. Because of both are there, what is the answer? Binary search possible, log n. Right? Fine. I am thinking you are absolutely fine. Right. Let's see the next problem. So one problem we done. Let's see this problem also. It is also given in one of your previous paper. Let's see. Read the problem. Input. A sorted array of n distinct elements. In the place of n, 10 is there. A sorted array of 10 distinct elements. Right. Next one, output. Find the average number of comparisons required to find an element which is present in the given array. Find the average number of comparisons required to find an element which is present in the given array. Means you want to say that in the array of 10 elements you want to find out one person, right? To do that average number of comparisons how many? Average is asking, right? How to do that? How many elements are there? 10 elements. You are trying to find out one person who is present. Try to remember who is present. The person who is present in the given array is trying to find out what will be the average number of comparisons. Right? So I will explain now how this kind of problems will be solved. I will explain. Can you help me one small line now? 10 elements, whatever it is, you don't worry, 10 elements are there. Because of your applying this one sorted array. Right? These are the 10 elements. Please be careful. See, these are 10 elements. You can take whatever you want, 10 elements. Can you help me now? If these are 10 elements, you can take 10, 20, 30, 40 like that 10 elements. 1, 2, 3, 4 also okay. I don't have any objection. Let's give 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. 10 elements are there. If you apply binary search on this particular array to find out your to find out a element which is present, right? Average number of comparisons how many? I will try how to solve this kind of problem. Find the mid element as usual. Find mid element. 1 plus 10, 11 by 2. What is the answer? 11 by 2. What is the answer? 5 point something. 5 point something. Take the floor value 5. 5, right? So when you take the 5 as the root, because the 5 is the first person. 5 is the first person. So I think less than 5 will go this side. More than 5 will go this side. That's okay. Right? So this is the middle person. Middle person is your element, you stop. Otherwise go left or go right. Assume that. Right? So now once again same. Can you help me now? In this one, if you apply binary search, what will happen? In this one, if you apply binary search, see this one. I applied the binary search, right? I find out the mid element 5. This will, some people will go left side, some people will go right side. Whoever is the less than 5 will go left side. Whoever is more than 5 will go right side. Again in this area also. What is the answer? If you apply binary search, what is the mid element? 1 plus 4, 5 by 2. 2 point something, so 2. 2. Less than 2 one side, more than 2 other side. So 1 will go this side. 3, 4. Can you help me? 3, 4 binary search apply. 3, 4 binary search apply. What is the mid element? 3 plus 4, 7 by 2. 3 point something, so 3. Right? 3. Right? So 3 will be the root. Less than 3, no 1. More than 3, 4. 3 will be the root. Less than 3, no 1. More than 3, 4. 4 will go this side. In the similar way, I think 4 because of only one person, 4 contain only one person. Right? One person means you can stop. You know binary search algorithm very well. Again, same in this area. Can you help in a mid element? 6 plus 10, 16 by 2. Right? 8. 8 will be here. Right? Less than 8 will be one side, more than 8 will be other side like this. Next one, similarly, what is the binary search in this area? 6 and 7. 6 plus 7. What is the answer? 12. 13 by 2. 6 point something. 13 means 6 point something if you do divide by 2. What is the answer? I think 6 will be there. Right? 6 will be there. 6 will be the root. Right? More than 6, I think 7 will go like this. In the similar way, what about this one? 9 and 10. 19 by 2. 9 point something. So 9 will be there. Less than 9, no 1. Right? More than 9, 10 will be there. Right? Like this. Just find like this. Nothing, everywhere I applied the binary search. See, whatever way binary search is going on, right? I take care all the things. So 5, less than 5 one side, more than 5. Again in this area also binary search. 2 is the root, less than 2 one side, more than 2. Again 3 and 4 binary search, right? 3 is the root, less than 3 no 1, 4 one side. Same way this side, right? So I think if you apply binary search, 8 is the root, less than 8 one side, more than 8 another side. Less than 8, 6 and 7, 6 is the root, less than 6 one side, more than 6 another side. Right, like that. Next one, 9 and 10. 9 and 10. What is the answer? So I think 9 will be the root. Less than 9, no one there. More than 9, 10 is there. Like that, just draw the tree. For 10 and whatever way binary search is going on, all mid elements make as root. First mid 5. Inside, right, left side, first mid 2. Again in the next group mid, and so on. All the mids you find out. After doing all, can you help me one small line now? As soon as, right, in this array whatever you are doing, right, same thing I shown in the form of a tree, right, fine. Now see this one. Can you help in this tree, if you want to find out element 5, how many comparison? In this tree, if you want to find out element 5, how many comparison? One comparison, that is the meaning of mid element. So one comparison. In this particular tree, to find out 2, how many comparison? You have to come here first 5 less than 5, 2, I think 2 comparison. In this particular tree, to find 8, how many comparison? First to 5, 1, more than 5, I think 8, I think 2 comparison. So if you see in this level, what is the answer? 2 times of 2, 2 people, everyone is 2 comparison. And one more thing, what about this one? To find this one, less than 5, less than 2, less than 1, 3 comparison. It is also 3, third level 3, this is also 3, this is also 3. Can you see how many? 4, 4 times 3. Next one, if you go next level, what is the answer? This is 4 comparison, this is 4 comparison, this is also 4 comparison. So what is the answer? 3 people, 4. Right? For every person to find out how many comparisons, find out. Depending upon levels, comparisons will come. First level 1 comparison, second level 2 comparison, third level 3 comparison, fourth level 4 comparisons. Some people are asking, sir, for every person, why are you finding comparison? For every person, average is based on all the people. Right? See this one, an array of 10 people, to find out a element which is present. Average number of comparisons, how many? When you say average, every person to find out how many comparison. See this one, in this diagram, to find out 5, how many comparison? Directly mid. To find out 1, how many comparison? First to 5, left hand side mid element is 2, next one, I think 1 will come. Can I say to find out 3, how? First to 5, left hand side you go, mid is going to be 2, more than 2 means you go this side, again mid element 3, I think 3 compare, like that. Every element to find out the comparison. Add all of them, how much? So I think it is going to be 1, it is 4, it is 12, it is also 12. 12 plus 12, 24 plus 4, 28 plus 1, 29. Total number of comparisons are 29. Average 29 by 10. Finally 2.9. Average number of comparisons to solve this problem is going to be, what is the answer? To this problem, answer is going to be 2.9. 29 by 10, which will goes to 2.9. Right? Please be careful. This problem will be solved like this. Find the average number of comparisons required to find an element which is present in the given array. Array contains 10 elements which is sorted. Because of average, every person to compute how many comparisons. See, I drawn the diagram, right, so that it will become easy. Directly also you can do. Can you help me now? To find out 5, how many comparison? 1. Next one, to find out 2, how many comparison? In this side, root is this one, 2. Next one, to find out 1, how many comparison? 3. After this, you will come here only. Next one, in this one, how many comparison? 1 here, 2 here, in this 3 here. Afterwards, 4 here. Next one, in this area, who is the root? This one. After this is 2. Next, in this area, who is the root? I think 6, 3. Right, in the, afterwards, it will go to 4. Next one, in this area, who is the root? This one. Right, it is the 2. This area, what is the answer? It is 3. It will become 4, like that. It is looking like difficult, that is the reason I drawn the tree. Simply apply binary search to find out every person. Can you help me now? To find 5 on this array, to find 5 using binary search, how many comparison? 1. On this array, to find out 1, how many comparison? To find 1, first you will start here, 1, afterwards middle is 2, afterwards 1, 3. Next one, in this one, to find out 2, how many comparison? First start here, 1, afterwards middle is 2, 2 comparison. Can you say, to further 3, how many comparison? First 5 here, afterwards middle is 2, 2 here, afterwards 3 and 4, 3. Afterwards 4 is 4. Next one, right side I also see. To find out 8, how many comparisons? What is the answer? 2. First 5, afterwards 8. Next one, what about 6? 1, 2, it is a 3. Right, what about 7? 1, 2, right, 1, it is a 2, it is a 3, it is a 4. Next one, what about this one? 9, 3, 10, 4, like that. I am thinking you are okay, right? Same thing, draw. If you draw in the form of a tree, it will look easy. So some people are asking, sir, how this tree came? Nothing there. 5 root, less than 5, whatever is there, go left. More than 5, whatever is there, go right. Here also again same. 2 root, less than 2, whatever is there, go left. More than 2, whatever is there, go right. Again, in these 2 people, who is the root? Again mid element. Just do like that. Level indicate number of comparison. Total is going to be 29. Average is 2.9. Some people are asking, sir, to this problem, answer is going to be 2.9. I am okay. but right, average number of comparisons, right, using binary search. Average number of comparisons using binary search. What is the formula? Log n. For the binary search, average number of comparisons are going to be log n base 2. Then what is the answer? Log 10 base 2. What is the answer? Log 10 base 2. Log 8 base 2, 3. Log 10 base 2 is going to be 3 point something. But actual answer is 2.9. That is the reason I am saying. Listen everyone now. If someone asks you binary search, average number of comparisons how many? If someone asks you, right, say log n. Actually it is not log n, it is a big O of log n. Asymptotically log n, please be careful. Asymptotically means what? Some constant of log n. Now from today onwards, binary search algorithm, average comparisons, what is the answer? Big O of log n or theta of log n, like that you say. Now some people are asking, right, average comparisons for the binary search is going to be big O of log n, we are okay with that. Big O of log n, we are okay with that. For the 10 elements, what you done? Try to remember, whenever array size is very small given, do manually. Whenever array size is big given, who will draw this kind of thing? 100 elements are there, who will do like this? If you do like this one, GATE exam is over. So see this one, less elements are there, less elements are given, average, do like this. More elements are given, apply formula, log n base 2. Log n base 2 will be the answer asymptotically. If more elements are coming, then go for the asymptotical, log n base 2. Right? Less elements are there, please do like this. So some people what they will do is, this problem is given, they will apply log n, that is also correct. Asymptotically 2.9 and 3.2, both will be similar. What is there in that? Asymptotically both are same. Asymptotically whatever you done, if anyone applied log, absolutely fine, that is correct answer. But the problem is going to be whenever less elements are given, you have to do mathematically. Mathematically means exact answer. Right? Asymptotically means approximately 2.9 and 3 point something, both are asymptotically equal. Right? Please be careful. Less size, follow it. More log n you apply. Right? To say that point only, I am taken this problem to explain. Right? I hope everyone is fine. What is the answer of this one? Right? 2.9 is the answer. Right? Please be careful. Small, do like that. Big, apply log n. Right? Let's see another problem of binary search. This is one more example. Right? It is there in the previous papers. Please read it. I will also read, you can read. So I am reading now. See, an element in the given array of n elements. An element in the given array of n elements is said to be majority element. Is said to be majority element if it is appear in array more than n by 2 times. An element in the given array of n elements is said to be majority element if it is appear in array more than n by 2 times. How much time it will take to find majority element? How much time it will take to find majority element in the sorted array of n elements if majority element exists? So he is saying that in the given array, a element is said to be majority element if it is appear more than n by 2 times. More than n by 2. Name itself saying majority means domination, is a dominator. In the given array, someone is there who is repeating more than half. More than n by 2 times he is repeating. That element is said to be majority element. Then he is asking, right, in the sorted array, majority element already exists. In the sorted array, majority element already exists. To find him, how much time? In the sorted array, to find majority element, how much time? If it is already exists, see this one. If majority element exists, how much time it will take to find majority element in the sorted array of n elements if majority element exists? This is the given problem. What is the meaning of majority element? Any element which is appearing more than n by 2 times in the given array, that is called as majority element. Now next one, he is asking in the sorted array, let me round the major point. Sorted array given, majority element exists, right? How much time? These are the keywords. And he is saying how much time. Can you help in how much time he is saying means? He is asking best case or worst case. Of course worst case only, best algorithm. To solve this problem, if you write the best algorithm, what is the worst case? Right? I will explain. From here onwards problem is starting. Before that he said what the majority means, majority element means. From here onwards problem will start. I am reading the problem once again. An element in the given array of n elements is said to be majority element if it is appear in array more than n by 2 times. How much time it will take to find majority element in the sorted array of n elements if majority element exists? Right, fine. So I will give one nice answer, please see. See, it is a very interesting problem. It is given in the previous paper for 1 mark or 2 mark, I don't know. It is given. It is very, very important one. See this one. See everyone. See everyone now. So to explain this problem, I took one array. To explain this problem, I took one array. Can you see in this array how many elements are there? 10 elements are there. In this array, 10 elements are there. Can you say 10 by 2? 5. In this array, 10 elements are there. 10 by 2 is 5. What is the meaning of this one? 10 by 2, 5. The meaning is going to be, in this array, 5 elements are there. Right? Half is going to be 5. One element repeating more than half. One element repeating more than half means, I think more than 5. Maybe 6 times. Let's check who is that. 6 times someone is repeating. 1, 2, 3, 4, 5, 6 times. More than 5. That may be 6. That may be 7. Right? Can you help in this array? Majority element is exist or not? Yes. There is one element which is repeating more than half. That element is said to be majority element. In this array, majority element is going to be 20. Right? Some people are asking. Right? So what is the answer for our problem? Can you say for our problem? Right? See, read our problem. How much time it will take to find majority element in the given sorted array? Sorted array is, I think let me sort this, is given sorted array. Right? So to this array, let me write the sorted. Can you sort this? What is the answer? 10, 20, 20, 20, 20, 20, I think 6 times. One more 20. Next one. Afterwards, what is the answer? All 20 is fine. Next. Next is going to be, is there any 30? No. 40. Next. 60. 70. Just to sort it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what he is saying is, there is one array which is already sorted. Right? In that array, majority element already exists. He already mentioned majority element is already exist. Right? To find that person, how much time? You only say in the given array, if majority element is already exist, it is already sorted also. Then no doubt at all. What is the answer? Answer should be middle person. What is the middle person for the, right? What is the middle person for the 10 people? Right? Middle person for the 10 people is going to be, what is the answer? Right? It is very, I think whenever it is an even number, finding the middle is very difficult. This also middle, this also middle. Take any one. Right? So in the given, see this one, in the given sorted array, if at all majority element exists, he should be middle person. He should be middle person. Because of, right? See this one. Because of this person is, right? Because of it is even number, 2 middles may be possible. 5 also you can take, 6 also you can take. Can you help an easy given sorted array or unsorted array? Sorted array. What he said, majority element exist or not? Exist. In the given sorted array, if at all majority element exists, he should be middle person. Yes. Answer should be 20. If you want, you can check. You can take 6 also, 6th element also you can take 20. Right? So answer, what is the time complexity of this problem? How much time it will take to find majority element in the sorted array if already exists? What is the answer? 1. Simply take middle person. Don't confuse here. Whenever even number, 2 middles will be there. Don't worry. Odd number, exact middle is possible. Suppose that 7 element, 3 here, 3 here. One person is here. Odd number can be written as 2 into x plus 1. That plus 1 is middle. Even number is 2 into x only. 2 parts you can divide, but middle no one there. You can take from this group also, this group also. Right? That is the reason. So, can you help you now? Right? Because of he mentioned sorted array, I took sorted array. Because of he is mentioned majority element exists too, I took majority element. So, if at all majority element exists in the sorted array, he should be middle person. Don't bother, 2 middles are there. You can take any one. Answer is going to be constant. Can you say it is the worst case or best case or every case? Every case. Right? Every case. Right? Please be careful. It is a nice problem. Please take care. Don't bother about even number, odd number. They are small thing. When you are doing great problem, when you are doing great thing, small things will come. Don't worry. Because of even number, don't stop this. Because of odd number, don't stop this. Please be careful. Those kind of things you cannot do. They are small negotiations. Right? Fine. So can you say to solve this problem how much time? Order of 1. Which case? Every case. How? Directly middle element you take. Some people are asking, sir, how can you take directly middle element? In the array random access possible. Directly you can go there. Right? Fine. I'm thinking that you are okay. To this problem, answer is going to be big O of 1 or theta of 1. Right? Fine. Let's see the next problem. Similar kind of problem is coming. Let's see the next one. Same problem, similar kind of problem. You can read it. The reason why I explained that much in the previous problem is same thing is coming in another way. So that in this one less repetition will be there. Can you read this problem? One more problem. One more problem, read it. An element in the given array of n elements is said to be majority element if it is appear in array more than n by 2 times. Same definition. Next one. How much time it will take to determine majority element exists or not in the given sorted array of n element? Right? In the given sorted array of n element. Now see this, see correctly what he is saying. This problem, that problem, if you compare everything same, and one more thing I want to ask you, everything is same, it's okay. What is the difference between these two? See there. See this one. How much time it will take? That is okay, I am okay. To determine majority element exists or not, see this is the major line. To determine majority element exists or not. What he want to say, and one more, it is a sorted array. So given one is a sorted array, majority element exists or not, you don't know. How much time it will take to verify majority element exists or not in the sorted array? In the previous problem, majority element exists, confirm. Here not there or not there, you don't know. If there, return; if not there, return -1. You want to say that. In the given sorted array, if at all majority element exists, you return. If not exists, return -1. Means you have to determine. See, majority element exists or not, you have to determine. After determining, if you think that it is there, return. If it is not there, return -1. How will you do that? Right? How will you do that? Let's see. Let's see here. Now carefully listen. See, this is the interesting story. 10 previous input only because of sorted array. Let me take the same 10, 20, 10, 20, some array. 20, 20, 20, 20, 26 times. Right, I think total is 7, 30, 40, 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? See this one. In this sorted array, majority element exists. Then what is the answer? In this sorted array, majority element exists. Then what is the answer? Middle person. Everyone know. To this problem, if majority element exists, then middle person, that everyone know that. But what is the problem? Right? If I go to in the sorted array, if majority element already exists, then middle person it's okay. But he is saying that majority element may exist, may not exist. Please determine majority element will be there or not there. If there, return. If not there, return -1. That's what he is saying. Can you help? If at all there, middle person only. If at all there, middle person only. But the question is, right? What is the guarantee that is the majority element? If at all there, you only. But what is the guarantee that? What is the guarantee that is there more than n by 2 times? What is the meaning? You have to determine now. Is he repeating? If at all there, this only, confirm. Right? But how to determine is there more than n by 2 times? Very simple. Right? How to determine this is there more than n by 2 times or not is very simple. What will you do is, right? You know answer is 20. What will you do? Using binary search. Using binary search. Find the first 20. Using binary search. Find the first 20. Right? So answer is 20 only, but it is repeating more than half or not, I have to check. How to check? I am explaining now. See this one, just using binary search, find the first 20. Some people are asking, sir, how to find out first 20 using binary search? See the answer. I am checking. See the answer. Ask him, are you 20? Answer is 21, I know, but he is repeating how many times? I have to count. I am counting. Middle person asks, are you 20? Yes. You want to find out which 20? First 20 I have to find out. Because I have to count how many 20s are there. First 20 I have to count. See this one. I am asking, are you 20? Yes. Before also 20. Yes. Indication that he is not first 20. Go left side. I came middle. I am asking, are you 20? Yes. It's okay. Before also 20 there. Just do one comparison. Yes. Indication that he is not first 20. First 20 there. Left side. Go left. Right? Again middle person ask. Middle person this. 4 people. You can take 2 also, 3 also. Let me take 2. I am asking this person, are you 20? Yes. Before also 20 there, no. Right? Are you 20? Yes. Before also 20 there, no. Indication that it is the first 20. Right? Before him, no one. It is the first 20. So half again half, again half, again half until this condition will happen. What is the condition? Right? Wherever I am at the mid, I will ask mid person, you are 20, before also 20 there, no, then is the first 20. Using binary search, find the first 20. Using binary search, find the first 20. Yes, I find out. Can you help me out to find out the first 20? How much time? Because of you are applying binary search. Worst case log n time. So after finding first 20 is here, second place, right? Can you help me now? What will you do? Apply binary search once again to find out last 20. Some people are asking, sir, how? Let me check. Are you 20? Yes. Afterwards also 20 there? Yes. Indication that is not last 20. Go right side. Right, mid element find out. I think mid is here. Assume. Next one again ask. Are you 20? No. But I want 20. Then go left. Right, mid element again. Once again let me ask. Mid element. Are you 20? Yes. Afterwards next person also 20? Yes. Means he is not last 20. Go right. Next one. Are you only one person? Are you 20? Yes. Stop it. Only one there means only one, that is 20. Yes. Yes. Then you can stop. It is the last 20. Using binary search, find the first 20. Using binary search, find the last 20. Apply binary search 2 times. 2 log n. Right? Afterwards, can you say first 20 way, second place. Last 20 there, 7th place. Can you say 2 to 7? How many elements are there? If you want to find second index to 7th index, how many elements are there if you want to find out? This is the formula. Last one, 7th one minus first one plus 1 you do. 7 minus 2 is 5 plus 1, 6. If you want, you can count also. 1, 2, 3, 4, 5, 6. Right? See, second index to 7th index, how many elements are there if you want to count? This is the formula. Right? Last index minus first index plus 1 you do. Total number of elements will come. Can you say how many elements are there? 10. What is the by 2? 5. Right? I think comparing 5 and 6, 6 greater. So, I think it is a majority element. Can you say the algorithm once again? In the sorted array, if at all majority element exists, you have to return him. Otherwise, you have to return -1. How? What is the procedure? Right? If at all exists, he should be middle person. Just go to middle. After going to the middle, right? That middle person, whoever is there in the middle, that middle person, find, right? First time when he came, at which index it came, using binary search. Using binary search, find out the last index also. After finding first index you know, last index also you know, using this formula, find out how many elements are there. If this is greater than n by 2, then majority element exists. Suppose it is not greater than n by 2, return -1, saying that it is not possible. And one more thing, what is the first step? Find mid element. Second step, that mid element find out using binary search left side also first place, using binary search find out right side also first place. 2 times binary search 2 log n. Finally, right, log n. So, what is the answer? First 20 you have to find out. Last 20 you have to find out. Right, using binary search. Right, I explained also. If you have any doubt also, please verify yourself. 2 times binary search 2 log n. So, time complexity is going to be big O of log n. Can you say it is the worst case or best case? Can you help me? It is the worst case or best case? You only say. Right? To determine, you have to do this much work. Right? To determine, you have to do this much work. Some people are asking, sir, best case how much? Best case is very simple. Right? I will ask him. Right? I will ask this person. Are you, right? This person 20. Right? I will ask, before also 20? No. Means he is the first 20. Afterwards also 20? No. It is the last 20. Right? Order of 1. To say, I think I immediately I can say that. Right? I think there is no element which is existing like that. Anyhow, this is going to be worst case and average case. Worst case and average case. Using, right, first find the middle person. Right? Mid you find out, mid is 20. First find the mid 20. Right? Which is constant time. This will take constant time. After finding mid 20 constant time, now that 20, first 20 find out, last 20 find out, 2 times binary search. Right? Finally constant plus 2 log n, finally log n, right? Worst case and average case. It is a nice problem, please take care. Can you say previous problem, this problem, what is the difference? Previously he said that it is there already. It is there already, so just take middle and return. Now here, right, if there return, if not there, return -1. Right? Some working, some determination process is there. Further 2 times binary search I have to apply. Right? That is also okay. I think you are fine. So can you see where binary search here? To find first 20 binary search. To find out last 20 also binary. Some people are asking first 20 how binary search. If you want you can check. You are 20? Yes. Before also 20 because I want first 20. If you are 20 before also 20, yes, indication that is not first 20. First 20 is there on the left side. Go left. Next one again. Are you 20? Yes. Before also 20 because I want first 20. Before also 20. No. Then is first 20. Same way here. Right? See, let me ask this person. Right? Are you 20? No. But I want 20. Less than that, go left. Next one. Are you 20? Yes. Right? Before also, sorry. You want the last 20, right? You want last 20. Are you 20? Yes. After you also 20 there. Yes. Indication that is not last 20. Last 20 right side. Go there. So, are you small problem? Yes. Then stop it. If small problem, stop. So, I think left hand side I stopped at 2. Right hand side I stopped at 7. Right? 2 to 7. 2's are there. How many? 7 minus 2 plus 1, 6. Right? I think it is the comparing the n by 2, it is bigger. So, majority element exists. He is saying the determine exist or not. Yes, exist. What is the value? 20. I know that 20 exist or not, I don't know. I verified using binary search 2 times. That's a nice problem. Please you take care. See, similar kind of problem. Same thing only but small change there. Read this also. See, previous 2 problem and this problem similar model, small differences, right? Check here. An element in the given array of n elements is said to be majority element if it is appear in array more than n by 2 times, as usual like previous. Next one. How much time it will take to determine whether the majority element exists or not in the given array of n elements, right? It looks like previous problem, but see the major difference. How much time it will take? Okay, that's okay. To determine means majority element may exist, may not exist, you don't know, so you have to determine. To determine majority element exists or not, that is also okay. But the problem is in the given array of an element, see it is not sorted. He is saying that in the given array, it is not sorted. In the given array, right, just identify majority element is existing or not. If at all exists, please return. In the given array, not sorted array. In the previous problem sorted, majority element may exist, may not exist. But before that, majority element exists also, sorted also. Slowly one by one condition is removed. Now the problem here is, it is not sorted first of all. Majority element exists or not, we don't know. Right? How to solve this problem? I think this problem, previous problem difference, array not sorted, one story is going to be first to sort. One answer for this problem is going to be first to sort the array. Can you help? Sorting will take how much time? Sorting n elements, right? Best algorithm, med sort, n log n time. Sorting n element, med sort algorithm will take n log n time. Some people are asking how, right? After binary search, right? Next one is med sort only. In that I will explain clearly. Until that time you remember. To this problem, one answer is going to be, see this one answer is going to be first to sort. How much time? Using med sort you can do n log n time. After sorting is over, like previous problem, whatever you done, same thing. Previous problem answer you can take care because this and that same. After sorting both are same. How much time? Previous problem answer log n. Finally n log n plus log n. What is the answer? N log n. This is one answer. To solve this problem, right, answer is going to be first to sort. Afterwards, previous problem whatever you done, apply 2 times binary search to find out the first 20, to find out the last 20, after which will take log n, 2 log n time, right, n log n plus 2 log n, not into, n log n plus 2 log n, finally n log n. This is the one answer. One more answer there, please listen. One more answer there, carefully listen this. So let's see what is the way of finding. So I am going to explain how to find out majority element, right? How to find out majority element in the given array if it is exist, right? Even though array not sorted. I am explaining now. See this one. This is algorithm. Initially I value 0. See what will happen. Take the first element. Ask the first element. Is I 0? Right? Every element you have to check. What is the I? If I 0. Every element, right? Every element you have to do this procedure. Is I 0? Yes. If I 0, then what will you do? Right? if I 0, what will you do is m is equal to 10 you keep, then make I as I plus 1, right? I as just make 1. For every element just ask one thing, if I 0 then only this story. If it is I 0, then what will you do is, right, what will you do is just store in the m that value, then increment I value by 1, then it became like this, it is cancelled. Next time, see the next time. So the next time take 20 and ask, is I is, right, recent I value, is I 0? No. Is I 0? No. Then what will you do is, if I is 0, right, then previous story, if I is not 0, what will you do is, right, then you have to do one thing, right, this 20 and this m both are equal or not? No. If no, right, see this one, whenever I is not 0, then compare these two. If both are equal, then increment I by 1. If both are not equal, right, then cancel this one, decrement I by 1, 0 again. Those people who confused, again I am asking you, right, again same story coming, let's check here. Right, take the next element and ask, is I 0? Yes. If I 0, then what will you do is, right, just assign that value here, then make 1. Next one, right, take the 30 and ask, is I 0? No. If I is not 0, then what will you do is, compare both the elements are same or not. If not same, then what is the answer? Then decrement this one by again 0, then cancel it. Right, next one, again check, is I 0? Yes. Then what will you do? Then make it as, right, this element, then increment this one. Like this it is done, right, like this it is done. Now can you help, total story is completed, right, we are there here is a majority element, right, is repeated almost like one time. See this, one time extra, for every element it is cancelled, 10, 20 cancel, 10, 30 cancel, means for every one cancel, lastly it is left out, it is more than half. Right, this is the algorithm. I'm repeating algorithm once again. Right, for every element you have to check one thing. What is the answer? I 0 or not? I 0 means what? No one is bigger until now. No one is more. That is the meaning. I 0 or not, verify. Suppose if I 0, what is the meaning? No one is greater. Then what will you do? Make I as 1. Keep that person in the m. The next element which is coming, right, again it will check the I. If I 0, normal story. If I is not 0, what you will do is, okay, means someone is there. Now you will compare with that element m. Both are equal or not. If both equal, increment I by 1. If both not equal, right, just I decrement by 1. Right, m don't update. Right, m don't update. Right, this is the algorithm. One scan only. This algorithm will take one scan only. Right, it will take order of n time. Extra space also it don't take. One variable or two variables it will take. Some people are asking, sir, can you explain one more time? I am explaining. See this also. See everyone. Make sure that everyone listen this one. Right, let me check here. 10, 20, 30. Majority element there, you know very well. See the algorithm of it is working. Initially I 0. Right, now let's see this one. First element is coming, it will ask, is I 0? Yes, means initial. I 0, no one, I 0 means no one came until now. No one extra, that is the meaning. Is I 0? Yes, then what will you do? In the m store that element, then increment I by 1, then cancel it. Next one, next again one more element is coming, asking, is I 0? No. If I not 0, means someone is there, then compare. These two are equal, yes, then increment this one by 1. Because of equal, then increment this one. Next one again come, is I 0? No, means someone is there. Then asking, both are equal, yes, I increment. Next one again come, right? So is I 0? No, then compare, both are equal, no. Indication that both are not equal, okay, to him one cancellation should be there. So 2, this is cancelled. Next one, right? Is I 0? No, I 0? No, right? To him asking, both are equal, no. Then what is the answer? Decrement 1. At the end, see 10 is majority element. Previously also 10 is majority element, now also majority element. Right, fine. Now see this also. See everyone, this one also. 10, 20, 30, 40, 10, 20, 30, 40, 50. Is there any majority element here? See, carefully listen this one. Is there any majority element here? Let's check. No majority element. Let's see what will happen. See, make sure that you listen this one. Let's see what will happen. I value 0. Start. So is I 0? Yes. M is equal to 10 you store. then make I as 1, cancel it. Next one, 20 coming, is I 0? No. Then both are equal? No. Then it is 0, cancel it. Next one, is I 0? Yes. Then if it is 0 starting, store this one, make 1. Next 40, is I 0? No. Then both are equal? No. Then what is the answer? Make 0. Next 50, is I 0? Yes. Then what is the answer? Make this as 50, make 1. Right? Like this. Can you help me at the end of this one? At the end of this one, if you observe, right? So at the end of this one, if you observe, right, what will happen here? Right? 50 came. 50 came. See this one, actually there is no majority element. At the end, one element is came. Actually there is no major element. At the end, right? At the end, one element is came. Right? Some people are thinking that, sir, it is not a majority element. Then this algorithm failed. Nothing there. After, see this one, if majority element is there, this algorithm will give. If majority element is there, he will give. If majority element not there, he will give some element. Right? So we don't know is it majority element or not. If there, confirm. In the sorted array, in the unsorted array, if majority element exists, he will give answer. If majority element not exist, it is looking like a wrong answer and all. What we will do is, after doing this work, right, majority element is looking like 50, take this 50 and ask, right, 50 came how many times? Ask everyone, are you 50? No. Are you 50? No. Are you? One more scan you will do. If majority element not exist, some element will come, right, take that element, scan one time, one more scan, right. I think doing this one is n, scanning is one more n, 2n, then also order of n. Verification also same, right. So in the given unsorted array, majority element exists, n is enough. In the given unsorted array, majority element exists or not, we don't know. If it is there, written, otherwise written -1. Then what will you do? Do this procedure first one time, right. One scan is n, afterwards one more verification, one more scan, 2n. Finally order of n. This algorithm again I am saying, right, take the first element. Take the first element, ask is for every element you have to do like this only, right. Take the first element, ask I 0 or not. If 0 starting, then what is the answer? In the m, store the first element, then make I as 1, right. Take the next element, ask I 0. If I 0, then do like just make it as 1, right. In the place of m, store that. If I not 0, then check elements are same or not. Both the elements are same or not. If same, increment I by 1. If not same, right, make I value again decrement the I value, then go further. It will continue like this, right. Fine. So can you help me now? This entire story I want to ask you one small. One is going to be sort and do this n log n. If you follow this algorithm, right, in unsorted array, let me write now, unsorted array, right, if majority element exists, right, time complexity n, unsorted array, majority element, may exist, may not exist, may exist. In unsorted array, majority element may exist. See, here majority element will exist. See, unsorted array, if majority element exists, it is may exist, may not, or may not. If you want, I will write may not, maybe, may not. Right, then what the answer is? One scanning is n, actual algorithm, this algorithm, plus one more verification purpose, one more n, 2n. Finally, it is also order. Right, like that. This is a nice algorithm, right. In the internet, if you type, this is a nice algorithm. In the internet, if you type majority element finding in the given array, you will see this algorithm. Yeah, let's see one more problem. On binary set, see the one more problem. I'm reading, roughly I'm reading this. There is an array of n elements in which until some position all are integers and afterwards all are infinite. Then how much time it will take to find first occurrence of infinite? Right? I am reading the problem again. There is an array of n elements in which until some position all are integers and afterwards all are infinite. Then how much time it will take to find first occurrence of infinite? Right? So I will take the one example, then only you will get this story. Let me take one example. One array, positions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6 and so on 17, right? 17 elements are there. Now what he said, there is one array, it is not sorted also, see, he is not mentioned sorted. There is an array, not sorted array, there is an array of n elements in which until some position all are integers. Let's see, until some position all are integers, negative, positive, anything, because he is not mentioned. Let me write here. So otherwise let me use same color. Minus 10, minus 20, minus 30, 50, 60, 70, minus 3, minus 2, 65, 75, infinite, like this. Until some position all are integers and afterwards all are infinite. Some people are asking, sir, how to write the infinite inside computer? It is an algorithm. It is a algorithm, right? Just we will see mathematical kind of thing. Right? While writing inside computer, you can write whatever way you want. Right? Some people are asking, then how to store infinite inside computer? In the place of infinite, store hash, store dollar, what is there in that? Any symbol, some special symbol. Right? I am repeating once again. There is one array. In that array, until some position integers are there, that may be negative or positive, and after that all are infinite, right? Something like that. How will you represent infinite inside system? In the place of infinite, you can keep dollar symbol. In the place of infinite, you can keep at the date, what is there in that. You can keep any special symbol. Integers followed by infinite, right? That's okay. Next one. What he is asking, let me check. Then, see this one. Then, how much time it will take to find first occurrence of infinite? He is not asking finding infinite, first occurrence of infinite. How much time it will take? See this one, until some position integers and afterwards infinite. Please be careful how to find out first occurrence of infinite. This problem is, I think, easily you can handle. Let me check. Is linear search possible? For this problem, linear search possible or not? Ask everyone. Start from here, ask everyone. Are you infinite? No. Are you infinite? No. One loop. Are you infinite or not? Are you infinite? Yes. Stop. Right? I think to this one, linear search is possible. Let me write here. To this one, linear search possible. Linear search on n elements possible. Time complexity big O of n, worst case. Time complexity is big O of n, worst case. Right? Next one. Some people are asking, to this one, linear search is okay. But what about binary search? I think you know, binary search also possible. Let's check here if you want. Let's see. See everyone. Just find mid element. What is the mid element? 1 plus 17, 18 by 2, 9. Right? Just go to 9th place. Just go to 9th place. Yes, I went 9th place. Ask the 9th place person. 1 plus 17 is 18 by 2, 9. 9th place person ask. Right? Are you infinite? Ask him. Right? He said no. If at all infinite, stop. That is the best case, it's okay. Ask him, are you infinite? He said no. If it is not infinite, what is the meaning integer? Right? So if it is not infinite, it is integer only. You know, until some position integer and afterwards infinite. I asked this person, are you infinite? No. He said I am integer. If at all it is integer, but I want infinite. So what should I do? Go right side. Because I know after integers infinite will come. Are you infinite? No. Means he is integer. But I want infinite. Means after these infinites will come. Then go right side. That's fine. Next one. Again mid element find out. Ask him. Are you infinite? He said yes. Are you infinite? He said yes. Can you help me now? Are you finding infinite or first infinite? First infinite, ask him. Are you infinite? He said yes. If at all you are infinite, before you also infinite, before one step extra, before you also infinite, yes, indication that he is not first infinite, before him something, then go left. Right? Again ask the middle person. Are you infinite? Yes. Before also infinite? No. Means he is first infinite. Right, like that. So I am asking, are you infinite? No, means integer. Afterwards infinite, then go right. Next one, are you infinite? Yes. But I want first infinite. Before you also infinite. Yes. Then I want first infinite. Before me something, then go left. Are you infinite? Yes. right? He said yes, he said yes. So next one, before also infinite, no, means he is the first infinite, stop it. So like that you have to do. Can you see how much time it is? Log n, right? So worst case is going to be log n. Binary switch algorithm on n elements, time complexity is big O of n, sorry, binary switch, right? Big O of log n, right? Worst case and average case, right? It is the right. This is also worst case and average case here is going to be n by 2, which is nothing but n. So for this problem, binary switch possible, log n. You want the best answer, right? Best answer is going to be log n. That is the answer for this. Some people are asking, sir, if it is integer, why are you going right side? You know, until some place integer and afterwards means you have to go right side. Next one, some people are asking, sir, after seeing the infinite, why don't you take answer? I want first infinite, not any infinite, first infinite. If you are infinite, before you also infinite, means you are not first infinite. I want first infinite, I will go left. Are you infinite? Yes. Before you also infinite? No. Then is the first infinite. Right? Fine. So I am thinking that you are absolutely fine. Let's see the next problem. One more problem. See this problem. Same thing like previous problem, but small difference is there. Let's check. There is an array in which until some position all are integers and afterwards all are infinite. Then how much time it will take to find first occurrence of infinite? Like same problem, but difference between this problem and previous problem, if you observe, difference is going to be in the previous problem there is an array of an element, see, an array of an element, but here array size is not there. There is an array in which until some position all integer and afterwards all infinite. Then how much time it will take to find the first occurrence of infinite? This one. Remember, array size is unknown. See, array size not given. Previous one size given, now size not given. Previous one, exactly like previous problem, previously size given, now size not given. If you want, I will check. Let's go to the previous problem. This is the previous one. An array of an element, it is the previous problem. N elements, size given, right? Here size not given, right? How will you do that, right? How will you do that? I will explain. Let me deal with this. This problem how to solve? Size not given. Array having size, it's okay, but it is not given. It's not given. How will you do that? On this example, I will explain. This problem, previous problem difference is here size given, right? In the next problem, this is going to be previous problem, right? So it is the next problem. See, here size not given, in the previous problem size given, right? Let's see what the answer of this. Previous problem, this problem difference is going to be in the previous problem size given, right? Here size not given, right? How to do that? Can you help me now? Can you apply linear set? Size not there. Can you apply linear sets? Yes, I can apply. Even though size not there, array having size no doubt. Array having size no doubt, right? Without size, how can you apply linear set? Array having size which is we don't know. See, unknown. Array having size which is unknown. Right? How will you solve this problem? Let's check here. If you want to do linear set, take something like, right, one while loop. While 1 true. While 1 is always true. While 1 true, then ask every person. I is equal to initially assume that 1. While 1 true, go inside. What is the answer? Right? If a of I is equal to infinite, no. Right? If a of I plus plus increase, ask everyone. While 1 true, ask every person. Whenever you saw the first infinite, stop it. So to this one linear set possible even though size not there. How? This may be the case. If you want, I will write roughly. I will say this one while 1 condition true, inside you can ask, right? Initially I is equal to 1, right? If ai is equal to infinite, right, then stop, otherwise I plus plus, it will continue. If ai is equal to infinite, return I. Otherwise, I plus plus, continue. Wherever you get infinite, stop, like that. Linear set possible, everyone know that. Only for namesake I written. The question is going to be, is binary set possible? Size not there, right? Array, linear set possible, it's okay. Is binary set possible? Size not there. Some people are asking, sir, binary set also possible. If binary set is possible, what is the first step? If binary search is possible, what is the first step? First step is going to be, listen, first step is going to be, right, find mid element. First step is going to be find mid element, right? Please be careful. But if I want to find out mid element, there is no size. How I will find out? Right, like this. See this one. Binary search also possible for this problem. If you want to apply binary search, size required, size not there, but still you can do binary search, right? Like this. Like this you can start. See this one. This is the way. Ask this person. Carefully listen. Ask this person. Right? Are you? Make sure that everyone listen. I am asking this person. Are you infinite? Are you infinite? He said, are you infinite? He said no. Right? Then if at all he is not infinite, ask the, just to do this position into 2. Are you infinite? Right? See, so I am asking first person, are you infinite? He said no. Then index multiply by 2. Then ask the second person, are you infinite? No. Then multiply the index by 2, 4. Ask this person, are you infinite? No. Multiply by 2, 8. Ask this person, are you infinite? No. Multiply this. So instead of asking everyone plus 1 plus 1 plus 1, multiply by 2 ask. Just grow little bit faster. Ask first person infinite? No. Because of integer, go right. Next one, are you infinite? No. Because of integer, go right. While going, just multiply 2. Ask this person, are you infinite? No. Right? Multiply by 2. What is the answer? 16. Next one, are you infinite? Are you infinite? You can stop. Are you infinite? Yes. I think what is the meaning? Size came. Size came. Now in this area, you can do your 1 times binary search to find the size. Now when you saw the infinite, stop there. So even though further there is no problem, because you want to find out first infinite, what is there in that. Even though further elements are there, don't care. Right? So I think to find out the size, 1 time binary search. Right? Afterwards in this area, you can do like previous problem. Can you help now? When you saw the infinite, stop it. Right? Most probably this will be the answer. It's okay. Otherwise also no problem. One more time you can apply binary search in this area. Now some people are asking, sir, how to apply? After finding the index, how to find? Right? It's normal story. What is the answer? 1 plus 16, 17 by 2. 17 by 2. What is the answer? 8 point something. 8. Ask him, are you infinite? No. Then go right. Are you infinite? Yes. Ask previous also infinite. Yes. Go left. Are you infinite? No. Go right. Only one element. Stop it. That is the answer. The only thing is, because of we don't have size, we cannot do divide by 2. When you cannot do, because of size you don't know, when you cannot do divide by 2, you can multiply by 2. If you know size, right, from the top onwards, keep on cutting. If you don't know size, from starting onwards, do plus, right, into 2. Linear search and this one same. Linear search plus 1 plus 1 plus 1. Here multiply by 2, multiply by 2, multiply 2, like this. Always multiply until your required thing will come. Right? When you saw the infinite, stop. Okay, in this area my element will be there. In that area you can apply the binary search like previous problem. So 1 log n, right? First time log n for finding size. Second time log n for finding first infinite. Right? Total is going to be 2 log n. Finally log n. Binary search possible even though size not there. Binary search possible. Right? Which case it is? Can you help in which case? Worst case and average case. Some people are asking what is the best case? When I started here itself maybe I will get infinite. Here itself maybe, then I will stop. Right? Best case is 1. No one will ask you best case. What is the worst case? Right? Previous problem, this problem same. The only thing is size finding is problem. How will you find? Because of size not there, you cannot do by 2 by 2. Because of I cannot do by 2 by 2, but I can do multiply by 2. Everyone now, divide by 2, reverse is multiply by 2. Right? That is the reason it is possible. To this problem, binary search possible, answer is log n. This problem, previous problem, same. Right? See this problem also. One more problem for binary search. Please see. A sorted array of n elements. A sorted array of n elements in which you need to find 2 elements so that their sum is 1000. It is a sorted array. N elements are there in that array. You have to find out 2 elements, any 2, so that their sum is 1000. To do this work, how much time complexity? Right? Best algorithm if you write, worst case how much? Right? Let me do right roughly. See this one. 100 sorted array. 200, 300, 400, 500, 600, 700. This is the array. Sorted array, so I took one sorted array. These are indexes. These are the indexes, right? It is a sorted array. I think everything is absolutely fine. Now, how to find out? Can you say, do you want to find out one person or two persons? Two people. You have to find out two people, two elements. If you want, I will write two people A and B. You want to find out two people A and B so that their sum is 1000. In this array, find two people A and B so that their sum is 1000. Right? How it will be done? Right? How it will be done? You don't want to find out one person. You want to find out two people. Some people are asking, sir, one I know how to find out. Some people are asking, one linear search you can do. One, right? But two people finding linear search how? Now you can do here also linear search. Two people finding linear search how? Right? But one thing, standard linear search you know very well. Same thing you can use here, but in the little bit nice way. See how? Two people you want to find out. This is the way. Listen, this is the way. If you want to find out two people, right? So this is the answer. Assume that first person is A. Assume that first person is A. This person is A, confirm, assume that, right? Second person purpose, right? You can try the linear search. What is the answer? So first person is this, right? So second person you add both of them. If both the sum is 1000, stop. If not, right, you can go slowly. A plus B. Equal, right? Stop. Otherwise A plus B. Otherwise A plus B. Otherwise A plus B. Otherwise A plus B, like that. So A fixed, right? For the purpose of B, apply linear search. So what is the answer? If you are lucky, here itself will match. If you are unlucky, what is the answer? For A, no B is available. Can you see how much time is over? For the A, already for the purpose of B, you applied already linear search. How much time? Right? One scan you done. N time over. So if you are lucky, somewhere matching there. If at all no matching there, then what is the answer? It is not A. This is A. Again same story. So if first element as A, apply linear search to find B. If it is fail, second element as A, apply linear search to find out B. Right? Like that, continue. How many times? Most probably n times linear search you will do. To this problem, one answer is going to be this answer. See this one? N times linear search. N times, not one time. First person as A, apply linear search. N. Second person as A, apply linear search. Some people are asking, first person as A, apply linear search. For what? To find B. Second person as A, apply linear search. For what purpose? To find B. Like that, for every element apply linear search. N times linear search roughly, which will take what the answer? N into N. Right? Which will take roughly N square. It is the worst case. Right? Worst case is this is the story. Because of two elements you want to find out. Right? This is the answer. Some people are asking, sir, to this problem, right? Whatever you said until now, we are okay. But what about binary search? Is binary search possible or not? Because of this is already sorted. Binary search may be also possible. I will try that also. See that one? See the binary search here? See this one. This person is A. You have to find out B. It is already sorted. So you don't ask everyone. You will ask middle person. Is A plus B is equal to 1000? First person is asking middle person, is A plus B is 1000? If he say yes, stop. If at all he will say no, the next question is how much sum? 1000, 100 plus 400, 500, right? Sum is 500, but I want 1000, means you want more. If you want more, what is the requirement of going left? Go right. Right? Again ask this person, what is A plus B? 100 plus 600, 700, but I want more, then go right side. Right? What is A plus B? 100 plus 700, 800, but I want 1000. Right? I want to go further, not possible. What is the meaning? For the A, right, on the remaining array, I applied the binary search. I am unable to find out B. One time you applied a binary search for A, log n time over. Next one, second element as A, apply binary search again, log n. Third element as A, apply binary search again. So I think what is the answer? N times binary search. Right? Which will goes to what is the answer? N into log n. Finally, n log n. N log n. N times binary search, so n log n. So this is the answer. To this problem, what is the one answer? Linear search, n square. Binary search also possible, n log n. Right? Same. Now see the answer. One more algorithm there. Carefully listen that algorithm also. The purpose of saying this problem is that algorithm only. Right? What is that algorithm? See here. It is a sorted array. Right? You want to find out two people whose sum is 1000. linear search, binary search, that is okay. See the next one. One more algorithm. See this algorithm. Please learn new things. Problem to problem. New things learn. If anything new, it's okay. Supposing that I am explaining one problem, in that everything whatever you know that only came, then what is the purpose of attending? What is the purpose of wasting 1 year time? 1 year preparation you are doing means you should learn as much as possible. So 2 algorithms I said mostly you know. See this algorithm also. In the sorted array you want to find out 2 people whose sum is 1000, right? See one more. Assume that the first person is A, second person is B. Sorry, first person is A, last person B. Ask their sum. What is the sum? First person has A, last person has B. Ask, add both of them. How much? 100 plus 700? 800. 100 plus 800 is 100 plus 700 is going to be 800. Is it equal to 1000? No. Is it more or less? Right, less. If it is less, you added both. Sum is not 1000, but sum is less than 1000. Means you want more. If you want more, smaller one increase. See, small value. That is the big value. If you want more, smaller one increase. Again, 200 plus 700, how much? 900. I want more. 300 plus 700, 1000. Stop. Like that. Worst case, what can happen? Maybe A will come until here. Right? I think one scan. Both, I think A is their first place, B is their last place, right? I want more, increment the smaller one. I want more, increment the smaller one, something like that. So one scan from left to right, one scan. That is the one way. One more, see this one. I want 2 people sum, right? I want 2 people sum. Assume that it is not 1000, 300 assume. I want 2 people sum 300. See the answer. It is A, it is B. What is the A plus B? 800. You want 800 or less? Less I want. Bigger one decrease. Less, bigger one decrease. Less, bigger one decrease. Less, bigger one decrease. Less, bigger one decrease. Like that. So S equal. Stop. Right. One more worst case. What can happen? It will come like this. That is also N. Either left person will go to rightmost place or right person will go to leftmost place. Right. Anyhow, it is going to be one scan only. Right. Time complexity big O of N. One scan only. So what is this algorithm? Right. First place A there, last place B there. Just if it is equal, stop. If it is small, right, A increment. If it is big, B decrement. Continue, continue, continue. But sometimes what happened is, see this one. Sometimes what happened is, E will come half, E will come half. Right, E will come half, E will come half, like that. That is also N by 2 plus N by 2, which is going to be N. That is also okay. One scan only. Please check yourself. Here no linear search, here no binary search. Right? Every comparison, one person out. In the first algorithm, right, to eliminate one element, N, right, for every element N time required, N times linear search. For every element N, like that, N times N square. Here, for every element log N, but here for every element one comparison. Why? Right, just add the first one and last one. If sum is equal, stop. If it is less, so increment A, means one is gone. Or decrement B, one element gone. Here every one comparison, one element out. One comparison, one element. But here one element to send log N. Here one element to send N. But here N. So best algorithm is going to be, right? This is people used to say that greedy algorithm. Some name should be given, right? Somewhere I studied. It is a greedy algorithm. Greedy algorithm. Answer is going to be N. Right? Worst case. Please remember this. A first place, B last place, one loop is going on. According to requirement, either A will increment or B will decrement. One loop only, right? Order of N, worst case. Suppose this problem is given in the gate examination. First do this, N square. See the option. In the option N square there, less than N square, no one there, this only. Suppose N square there, N log N also there, then go further. So N log N is the answer. Suppose in the option N log N there, less than N log N not there, then don't go to this algorithm. Less than N log N there, that is the N there. So this is. Suppose less than this also there, I think may not be possible because minimum one scan required. You want to find out 2 people, minimum one scan required. Less than N, there is no chance at all. So to this problem, best answer is going to be N. Right? Please take care. And one more thing I want to ask you, this problem, is it sorted or unsorted? Is it sorted or unsorted? Please help me. Is it sorted array or unsorted array? Sorted array, that is the reason this story happened. If it is unsorted array, first to sort. If it is unsorted array, first to sort, which will take N log N, followed by last algorithm you can do. n log n plus this, which will goes to n log n. So if you want, I will write that also. See this one. If array unsorted, above story is sorted. If array unsorted, first step sort, which will take n log n using math sort. Second step, what is second step? Apply greedy algorithm, whatever we discussed until now, n, right, overall becomes n log. If array is unsorted, this is. If array is sorted, what is the answer? If array is sorted, if array is sorted, big O of n, worst case. It is, I think, what is the answer? Because of you have to sort every case. It is every case. If array is unsorted, right, every case is, because you have to sort first. Sorting will always take n log n. Fine. Take care about this problem. Right. Next problem. One more. See this problem also. Read this problem also. A sorted array of n elements in which you need to find two elements so that their sum is less than 1000. It is a sorted array. You have to find out two people whose sum is less than 1000, previously equal to 1000, whose sum is 1000 previously, now whose sum is less than 1000. I have to find two people in the given sorted array so that their sum becomes less than 1000. Less than 1000. Let's take this example. Less than 1000. 1, 2, 3, 4, 5, 6, 7. 100, 200, 300, 400, 500, 600, 700. This is a given array, right? In this given array, 7 elements are there, right? You have to find out two people whose sum is less than 1000. Sum is 1. I want two people, I will write here. I want two people, A and B, right, whose sum is less than 1000. Their sum is less than 1000. But how to find out? Can you see it sorted array or unsorted array? This one is sorted array or unsorted array? It is a sorted array. You want two people whose sum is less than 1000. Can you help me one small line now? You can apply linear search, you can apply binary search, everything fine. Because of it is a sorted array, you want sum is less than 1000. What is there in that? First two people add. That will be the answer. It is given in one of your previous paper for 2 marks. In the given sorted array, find two people whose sum is less than 1000. Because of already sorted, you want two people sum is less than 1000. You add first two people. If you add first two people, how much? 300. Right? Definitely it is less than 1000. Answer is this. Can you see how much time complexity? Order of 1. Which case? Every case. Every case this is the answer. Some people are asking, sir, can't I apply linear search? You can do. Same thing like previous case, n square. You can apply binary search also, n log n. But the best answer is this. Take first two people, add them, their sum should be less than 1000. Suppose some people are asking, first two if I add, sum is not less than 1000, then what is the answer? No one there. Two small people itself is more than 1000. Who can give less than 1000? So that is the reason. First two people will decide the story. First two people will be the answer. If not first two people, no one can give. So answer is going to be order of 1 every case. Suppose assume that it is not less than 1000, it is greater than 1000. Last two people you take. You want two people whose sum is greater than 1000. Last two people you take. Then it will work out. Less than means first two people, greater than means last two people. To this problem, answer is order of 1 every case. And one more, the answer whatever written, is it for sorted or unsorted? Right, sorted. Sorted, this is the story. Some students are asking, same problem answer, unsorted, what will you do? Same problem, unsorted, what will you do? You only say, if it is sorted, first two people you take, that is okay. If it is unsorted, what will you do? If it is unsorted, what is the one worst algorithm? If it is unsorted, see the one worst algorithm. What is the answer? First to sort. Afterwards, what is the second step? Right, this algorithm you can take first two elements. Right, first two elements you take. First step is sort, second step is going to be, right, first 2 elements you take. Sorting will take n log n, first 2 will take constant, overall n log n. This is if array not sorted, one algorithm. See the second algorithm, right, unsorted, right, first to sort, second step is going to be first 2 elements you take after sorting, that will be the answer n log n. One more algorithm is going to be, see everyone, one more algorithm is going to be, right, because of it is unsorted, but answer is going to be first 2 people. Why answer is first 2 people? First 2 people are first, right, 2 minimums. In the sorted array, first 2 people are 2 minimum, I think problem is over. If array is unsorted, one is worst idea, sort and take first 2. If you want first 2 elements, if you want first 2 minimum element, why are you sorting total array? What is the best idea? Using find max min algorithm, the thing which we discussed in the last class. Using finding max min algorithm, what will you do? Find 2 times minimum. First time find minimum, one for loop. Second time also find a minimum. I think 2 minimums you find out. Right? So second step is going to be this one. Find 2 minimums. Find 2 minimums. One minimum, one for loop. Scan one time, one minimum will come. Remove that element. Scan one more time, one more minimum will come. Find 2 minimums. Find 2 minimums. Right? If you find 2 minimums, what is the answer? 2n time. This is algorithm. Find 2 minimums. Right? Take one for loop. First time find minimum. Right? Afterwards, second time also find out. After finding first minimum, remove that. One more time you apply second minimum. I think you can do 2 scans, 2n. Time complexity becomes big O of n. Right? Please be careful. If sorted, time complexity 1. If not sorted, time complexity is n. Some people are asking, sir, what about this one? The problem with this algorithm is correct answer coming, it's okay. It is taking more time. Why? If you want 2 minimum, how can you sort total array? You want only 2 minimum. If you want only 2 minimum, find 2 minimums only. Don't sort total array. You know what is the meaning of sorting? Meaning of sorting is you are finding all minimums. If you want only 2 minimum, you are finding all minimum, means you are doing some unnecessary work. So this also correct. N log n, it is the maximum time taken. Best answer, find 2 minimums. Some people are asking, sir, how to find 2 minimum? Just apply, find, right, straight max min algorithm. Straight max min algorithm apply, but there you are finding minimum, maximum. Here you are finding minimum 1, minimum 2. The same thing only, just change variable. There max min replaced by, right, min 1, min 2. Just one scan you do, right, one scan for first minimum, one more scan for second minimum, 2 scans you do, 2n, which will become cn. Right, this problem is interesting one, please you take care. Sorted array of n elements in which you have to find out 2 people so that their sum is less than 1000. Sorted, first 2. Not sorted, sort n log n. One more, why are you sorting total array if you want 2 minimum? Find 2 minimums, right? Manually find 2 minimums manually. Manual means taking one for loop checking. So I think 2 minimums, I think 2 loops, 2n, finally order of n. You can apply linear search also, n square. You can apply binary search also, n log n. Comparing them, these are better. Right, fine. So listen everyone, for the binary search problem, for the binary search algorithm, in the previous papers, whatever questions are there, few problems I explained. I am thinking most probably you are really fine with all of them, right? If you are not fine also, no problem. Some idea I given, right? So I think you have problem, you have answer also, please verify yourself. I am thinking that really I explained very well. If you think that somewhere not clear, really it is not a problem. You have problem, you have answer, you have video also in front of you, you can replay again also, right? Please do that. If you see the binary search algorithm properly, right, small problem it's okay. If it is a big problem, right, you will go to the else part. In the else part, what is the first step? Right, divide. Mid is equal to I plus j by 2. Right, divide. Next one, after divide is over, mid element is your element or not, you will check. If it is true, then stop, that's fine. Otherwise, you may go left, you may go right. You may go left, you may go right. I think that part is called as conquer. Solving sub problems is called conquer. First to divide, afterwards conquer, sub-problem. Do you believe or not? If you want, you can check the binary search algorithm. After conquer step is over, there is nothing further. What is the meaning? No combine. In binary search algorithm is the application of divide and conquer, it's okay. But in this algorithm, if you observe, only divide there, conquer there, but there is no combine. So that is the reason binary search is considered to be one of the partial application of divide and conquer. It is not a fully application of divide and conquer, it is a partial application of divide and conquer. The reason is going to be there is no combine, just divide, conquer, right? Those two itself solving. Divide and conquer itself solving, what is the requirement of combine? If really required, combine. Really not required, why you combine? So this is the point which is pending, right? I hope you got. So binary search algorithm is the partial application of divide and conquer, not fully, right? Fine.